9, 8, ignition sequence start. Engines armed. 5, 4, 3, 2, 1. All engines running. Launch commit. Liftoff. We have liftoff at 9:34 a.m. Eastern Daylight Time.
That was the launch of Apollo 15 on July 26, 1971. Now let's take a closer look on how this 3 million kilogram rocket got off the ground. The Saturn V rocket model relies on 3 crucial stages, each with its own engine firing in sequence. The first stage lasted for the first 168 seconds of the launch, starting 7 seconds before liftoff. This stage alone weighed in at 2,300,000 kilograms, which is 77% of the total mass. This enormous fuel cell propulsed the rocket to an altitude of 67 kilometers and a velocity of 2,300 meters per second, which is over 6 times the speed of sound.
One minute after liftoff, the Saturn V is already supersonic.
Well, the Saturn V is still the most powerful machine that man has ever devised. 20 tons of fuel a second, 7.5 million pounds of thrust.
The first stage piece had an acceleration of 40 meters per second squared. After experiencing 4 Gs, the first stage is released and the second stage kicks in to send the rocket to a velocity of 7,000 meters per second. The rocket is now ready for its orbit.
At 40 miles high, it's still accelerating.
When you staged, you were thrown forward in the belts and then backward in the belts.
And I thought I was being catapulted through the instrument panel.
The third and final stage fires 2 times. The first to propel it into its orbit, and the second to take it out of its orbit and into space.
From the second stage of the Delta vehicle as it continues to rise, now 1 minute 39 seconds after liftoff.
The rocket then orbits the Earth 2.5 times. Each revolution takes approximately 90 minutes. The reason for orbiting the Earth is mainly to reach a high enough velocity to escape the Earth's gravitational pull. A 7,800 meter per second velocity is needed to escape only Earth's gravity, but an 11,000 meter per second velocity is needed to reach the Moon and other planets. Another reason for orbiting is to perform one last check of the rocket before leaving for space. One thing that helps speed the rocket up is taking off in an easterly direction to use the Earth's velocity. This adds an extra 400 meters per second onto the rocket's velocity. To wrap it up, this intricate series of staging is what propels the massive rocket to a velocity of 7,000 meters per second and into deep space.